Okay, so for our last spreadsheet assignment, this is going to be looking at, if we look at the final problem, is going to be a beam spreadsheet. And what I've done is I've chosen to have you guys write a spreadsheet that is going to be based on a simply supported beam. Okay? Now, in the handout that I gave you, all right, you'll notice that the first sheet here, I did an MD solids breakdown, okay? And I expect you to do the same because it's tied to a similar, and then you can check your answers to be sure that if you put in any other lengths besides the kind of critical sections, you can then check your work as well, okay? So you'll notice that I have a simply supported beam. My beam is 10 feet long. Okay, that's why you see 10 feet up here, simply supported. And then I've got two forces. One at 3 feet in, which is a magnitude of 1,000 pounds going down. And then I have another force at 6 feet in at 3,000 pounds going down. Okay, and then my simple support out here at 10. The top here lets us know what the values of the external loads are that I added, but then also what are the values of the reactions at the support. So you'll see an AY here and then a BY. So those would be going up in these two directions. Okay? Then, as you can see below, the next is my shear diagram and then my moment diagram down below. Now, I'm not going to have you have these, created to draw them out, but what I am having you do is create a spreadsheet to calculate first the reactions at the supports, and then what is the shear at any given location or section, and then what is the moment at any given location along that length. Now, this is divided up in three distinct sections. We're going to have a section number 1 here, section number 2, and section number 3. Okay? And so what we're going to do is we're going to manually calculate some of these values and determine the equations we're going to be putting in. And then once we put we get that part of it done, we'll be looking at how we develop the spreadsheet or the things that you have to add to it. So we get to do manual static strength of materials before we start putting this in. So what I want to do is we are going to first determine the reactions at the supports to be sure that we understand how to get those numbers. And then we're going to be making 1, 2, 3 sections here, identifying what our reactions are inside or internally so that we can get the shear and the moment. Okay? So first things first, let's calculate what the reactions at the support would be manually. Now this is something that I didn't include in the handout, and we are going to be using the information we get from the manual calculations to guide us to what we're going to be putting into the actual spreadsheet. So even if you know how to do the statics and you know how to do the strengths and you want to watch, that's fine. But know that you're going to be using it then for the spreadsheet portion. So I encourage you to take notes on and follow along with what we're going over here. Okay? So for the first part here, first thing we're going to do is we're going to calculate the reactions at the supports. So I'm going to sum, and I'll put my little convention up in the corner here. Okay, I'm going to sum my moments around A equal to 0. All right, so I'm going to put my finger on A, and I know that P1 is 1,000 pounds, P2 is 3,000 pounds. Now, I'm going to be able to change those values in my spreadsheet, but this is the problem I'm using to generate what I'm going to be, putting into the spreadsheet. So I know that to calculate those, I'm going to then do the 1,000 pounds times my distance is 3 feet. Okay. As I rotate it or pull in that direction, it's going to go in a negative direction. Then I'm going to have 3,000 pounds times 6 feet, and that is going to also go in a negative direction. Okay. Then at BY, I know that there's going to be a reaction BY going up here. And so if I pull in the direction of that rotation, that's going to go positive. This is going to be BY times 10 feet. Those are all of the offset forces causing rotation around A, so I set this equal to 0. Okay? Now, I'm going to rearrange my equation to solve for BY. So BY is going to be equal to, now I'm not going to combine things before I put them over there, and you'll see why for when I put it in my spreadsheet. So I'm going to take my negative 1,000 times 3. I'm going to leave it in this form, but it's negative on the left-hand side, so when I move it to the other side, it becomes positive. So this is going to be 1,000 pounds times 3 feet. And then it's going to be plus 3,000 pounds times 6 feet. And then I have my BY here that stays on the left-hand side, and I'm going to divide both sides by the 10 feet. Okay? So my BY should come out to be, it looks like 2,100 pounds. Okay? All right. Now, the next thing I'm going to do is I'm going to solve for AY. Now I know that since I have BY already, and I know this to be 2,100 pounds, my only unknown here then is going to be my AY going up. So I can use my sum of the forces in the Y equals 0 equation, right? And I can say AY is going up minus 1,000 going down minus 3,000 going down plus 2,100 going up at BY is equal to 0. So when I take this and I put it on the other side, it's going to be AY is equal to 1,000 positive plus 3,000 positive minus 2,100, whoopsie, negative, or I'm sorry, minus, 2,100. And my AY will come out as a final answer to 900 pounds, I'm sorry, 1,900. And then that's going up. Okay. Now, what I'm going to do is I'm going to take this part, my statics part, the reactions that I just created, and let's look at how I'm going to put those into the spreadsheet. Okay? So, now for this spreadsheet, what I did was I looked at it and I created my tabs on the bottom or my sheets on the bottom accordingly. So you're going to need to have similar sheets. Now again, it's not going to look exactly the same. I'm just presenting the minimum that you guys have to do. So I have my first sheet here that comes up as my inputs. Okay. The second sheet I'm going to have is going to be my beam reactions. The third sheet, internal shear, and then internal moments. And it's just the magnitudes. You don't have to, draw the pictures or draw the graphs using that. So I'm going to go back to my inputs tab here. And my input tab is going to be kind of the overall information for what I put into MD solids, if you would. So the first one here is going to be the length of the beam. Notice that I'm keeping with the English units, so I used feet on there, so I'm going to use feet for my overall length. I call this the distance between A and B, and this refers back to the MD solids between A and B right here, because they call these 2 points A and B. Okay? Then you'll notice that I have F1 and F2. These are my two forces. So I have 1,000 and 3,000. Then I have a distance, and it says the distance from the left support to my force number 1. So that's the 3 feet. And then my distance from the left support, or point A, to force number 2. So what that's doing is it's identifying the 1,000 going down at 3 feet, the 3,000 going down at 6 feet. Okay? Now, on my spreadsheet, we'll worry about the X1s, 2s, and 3s in a little bit. All right? We don't have to worry about that just yet. This is just for the beam reactions. Now, the two reactions that I have are at A and at B. And with the arrangement that I have, they're only going to be in the Y direction. I don't have forces going at angles or anything like that. So my output here are going to be the reactions at A and B. Now, this is going to automatically calculate this, and you'll notice that I have an equation in there. Okay? Now, let's first look at what we created on our spreadsheet here. The first thing I did was I created my moment diagram to solve for BY. Okay? Now, as I look at BY, and this is why I separated it out and I didn't do my combining on the left-hand side mathematically and then put it on the other side, because now I'm going to say BY is equal to, this is my equal sign for my Excel spreadsheet, okay? And my 1,000 here is what I'm going to call F1, okay? My 3 feet was D1, okay? My 3,000, I'm going to call that F2, and my 6 feet was D2. So when I go back to my inputs, here's my F1, here's my F2, here's my D1, and here's my D2, okay? And then underneath here, the 10 feet was my overall length, which up here was the very first thing I put in, okay? So now on the second sheet, I am going to write that equation in for BY, but I'm going to reference the stuff that I had inputted on the first sheet, okay? So beam reaction, I'm going to go down to BY here. I'm going to get rid of the equation that I wrote, and we'll put this in kind of together, okay? So looking at that top line, I have F1 times D1 is going to be my first set of parentheses. So I have my equal sign here. I'm going to switch to the input over here. I'm going to click on F1, and then I'm going to do shift for 8 for the multiplication sign times D1. And then I'm going to hit enter. Now the reason I did that, I'm doing this in baby steps, because what I realized is if I go back and forth and I don't hit the enter key, this gets kind of weird. Okay, so you can choose to do it in steps, or you can try to do it all at once. I was having difficulties. And now I put my parentheses around my F1 times D1. Okay, then I am going to add plus my next one here. And now I'm going to go back. I'm going to continue on here. My input is going to be F2 shift times D2. Okay, and then enter. Yeah, it's going to be kind of mad about this. I'm not done yet. Don't worry. So I'm going to continue on. That's my top line. Now I'm going to put parentheses around. No, I'm not going to. I'm going to do this because I did this at home. I'm going to do divide by my length. My overall length was right here. And then I'm going to hit enter. Now, look at the number that I have here. It says 4,800. I'm supposed to be getting 2,100. This is why we want to work them out and know the answers beforehand. What did I do wrong? Maybe caught on because I stopped doing what I was going to do to make it right. I have to put parentheses around the whole top because the 10 has to divide. Because right now, if I look at my equation, it's going to take the 3,000 times 6, divide by 10, then add the 1,000 times 3. Okay, so yes, watch your parentheses here. If you're not getting the correct numbers, separate this stuff out. It's amazing. Okay, and then enter. Now I get my 2,100 because then it did everything in the parentheses first and then divided by 10, and that's what I want it to do. Yes?
So this only works for like this problem, this spreadsheet.
For a setup like this, correct. But I can change my distances. I'll be able to change my distances and my magnitudes. But yes, yeah, this is.
So you can do like a force down, force up. You're gonna have to have a negative in there.
You can. You could put the negative in. That would be fine. And then you're just going to find that your values will be. Yeah. Yeah.
So pretty much only works for this.
This type of a setup, yes, a simply supported beam where you have on the outside and you've got 2 forces going down on the inside. Yes. Yeah. Mm-hmm. You could set 1 to 0 if there's only one. You could put multiple. I'm just starting with baby steps because this is really an introduction to. If you want to make it so that it's going to handle other types, that's okay, but it'll take you quite a bit longer. Yeah. If you let's say you would maybe you could add a tab for, let's say, a cantilever beam support or a fixed support, something like that. You could do that. I'm just not requiring that for you guys for this one. Yeah. But yeah, it has to be this kind of generic setup that we see here with the 2 forces in the middle, but you'll be able to change the magnitudes and the lengths of everything. Okay. Okay, so that's my BY. Then I'm going to put in AY. I'm going to get rid of this guy, okay, here. And my AY, I'm going to go back to what I wrote out, and I'm going to do this one right here. So my equal sign in my spreadsheet and my function is right here, the equal sign. So now my 1,000 was F1, my 3,000 was F2, and my 2,100 was the BY. Okay, my BY. Okay, so I'm going to go back here, and I'm going to do an equal sign, and I want to pull from the inputs up here where my F1 was, okay, and then I'm going to do the plus sign, plus F2, and then minus, I'm going to go back to my beam reaction. See, that's where, yeah, I'm going to go back over here. I'm going to hit my enter first. This is going to be 2 here. Wait. Enter. It's not going to like that. That's okay. And I'm going to finish it here because I need to do a minus and then the 2,100, the reference here. I only did it in stages just because when you are referencing a different sheet, it kind of, if you switch back sheets, it kind of doesn't remember. So that this one is going to be the 1,900, which matches what I have here. So it's literally the 1,000 plus 3,000 minus the 2,100. Okay. Now, let's just make sure. Let's check. So if, let's say I change something up here where maybe I change the magnitude of my force to 2,000. Okay. And the other force to 5,000. Okay. I want to make sure that this updates over here, and it did. Okay, you could check the numbers additionally to see if it actually is, but that's really the purpose. Okay, I'm going to put my 1,000 back in place and my 3,000. Okay. All right. So those are my beam reactions. I've got those done. Now what I want to do is I want to start determining what my shear and my moments are at any one of those sections that I'm in. So if I go back to here, as I said earlier, I identified the first section here just before P1 is going to be my section number 1. Then the next section is going to be this section number 2, which will be including P1, but just before P2. And then the last section will be number 3, which will be this section over here. Okay? So what I'm going to do now is we want to, actually I can stay there, we want to draw the free body diagram to look at the internal forces for this first section first. Okay, this is kind of taking us back a little ways to, it was chapter 10 in our book. Okay, so I am going to redraw, I'm going to call this section number 1. Okay, and I'm going to draw, this is going to be my point A, so this is going to be AY, which was 1,900 pounds going up. Remember, I add all external loads, including the reactions. All right, and then I'm going to draw this right before P2 comes into place, or I'm sorry, P1. I'm not going to include P1, so I'm going to stop it right there. Okay, now, I know that internally I'm going to have the possibility of 3 reactions, an X, Y, and a moment. I don't have any opposing X forces, so I'm not even going to draw that in there. It would be X, that X would be 0. But I do have a Y, right? I have a shear force here. This is going to be, I'm going to call this one, let's see what I call it, FY1. Okay? So it's the Y directed internal force for shear at section 1. And then I'm going to have a moment. If this is going, if I hold this and this is going to want to rotate counterclock or clockwise, my moment internally is going to want to go counterclockwise. So I'm going to call that moment number 1. Now, this distance that I'm going to identify here can be anywhere from 0, okay, to as far as 3 feet, okay, just before, not including that force number 1. We're going to call this x1, okay, that's going to be the variable that we call that. Now, I'm going to solve this as if we were at 3 feet because that's kind of our extreme, if you would, for the shear force and the moment. So as I look here, I'm going to sum my forces in the y equal to 0. There are only these two forces on my diagram here, so I don't have to do a moment to solve for one of these forces. So this is simply going to be a positive 1,900 pounds minus Fy1 is equal to 0. Okay. Then I'm going to solve for my Fy1, so I'm going to have a negative Fy1, that's the internal shear force. It's going to be equal to a negative 1,900 pounds. They both become positive. Okay. Now for this, as I look, this is the internal force, the shear force that I'm solving for. This is my equal sign on my spreadsheet, so the 1,900 here is my AY value. Do you see that? Okay. So this number I'm going to pull from the reaction sheet. Okay. So this is my shear 1. So let's go to the spreadsheet and let's see the internal shear, how we have this one set up. For section number 1, all right, now notice that I have a number, like kind of a range here. This is 0. 0 is going to be my left-hand side of my beam, to D1. So it's not minus D1, it's like 2D1. Maybe I should show that a little bit different. But all this is showing is a range from 0 to whatever my D1 distance was. My D1 distance, remember, was an input to the first force. So my D1 in this case, on this problem, was 3. I could change that if I wanted to, all right? But it's the zone, it's that first section. I could have that a different number, all right? But it has to be between there. So my internal shear. Now, this is, I call it an auto input because it's pulling this number right here from my first sheet. It's going to set it equal to D1 because that's my extreme number. That's as far as I'm going to go. For my shear forces in this case, they're going to be the same no matter what length I'm at up until that D1. Then it's going to change. Okay? So I have it set at 3 right now, and it's going to be that distance that was earlier. And that x1 comes from the input here, all right? x1 is one of the ones that I added additionally. I could put, remember this has to be, x1 has to be less than d1, so I could put 2 in here. And you'll notice that that'll update over here as long as it's less than whatever my d1 is. I'm in that range, if you would, right between here. So I can have a number anywhere from 0 to 3. It can be 1.5, it can be 1.2, it can be 0.3, okay, as long as it's in that range, because that represents that first section, okay? So, by force 1, this is going to be equal to the beam reaction at AY because of the way that this is set up. So, you'll notice here that my AY was the only other force that was present. So internally, Fy is only going to oppose that reaction force. And so I'm going to reference AY here. So on my spreadsheet, you'll notice here, this comes from the beam reactions sheet, C7. So because, oh, I must have, hold on, you're right. Let's move that. It's supposed to be C6, right? Mm-hmm. Hold on, oops, cancel. I don't want to do that. So, sorry. There we go, C6. Yeah. I know why it happened and it's my fault. So make sure you change that on that handout that I gave you. That should be to C6. So it's the 2100. Dang it. Yeah, I don't think it affected anything else. I think it must have been only that one spot. Let me just be sure that that's the same thing. Yeah, so C6 is here, and C6 is, oh, it should be okay. All right. Now, as we go down below, we're going to now go to the next section, all right? But I'm not going to worry about the shear right now. I'm going to move to finishing up section 1 and doing the moment. So then we'll see how the moment is put up. So as I go back over here, I'm going to finish up and I'm going to solve for that other reaction internally, which is M1. So I'm going to sum my moments equal to 0. And the first thing I'm going to be putting in here is M1. M1 is going in a positive direction because it's going counterclockwise. And then I put my finger on my reaction, and AY, you're going to notice, is going to want to turn so that it goes in a clockwise direction. So I'm going to have I'm sorry, not AY. We're going to put the numbers in. 1900 times, and I'm going to do 3 feet. That's the maximum moment at that point. Okay? And this is going to go in a negative direction because it's going to go clockwise. And then set that equal to 0. So now solving for M1, I'm going to put the negative 1900 times 3 on the other side. So M1 is going to be equal to 1900 times 3 feet. Now, again, the equal sign here is going to be the equal sign that I put in that cell for my function. So my 1900 pounds, remember, was my AY value from above. And this value of 3 feet is going to be the X value, X1, for that section. Remember, I can put in any value that I want. Now, the shear is not dependent on how far along here I am. That shear of 1900 will be the same until I hit my next force. But my moment value is dependent on a distance. So it changes as I go along, as seen on the moment diagram. Okay? So here my 1900 remains the same until I hit P1. Here my moment is going to increase. So it's going to be different for every one of the distances or the X values that I would put in there. So again, my X value for this first section is anywhere from 0 to 3 feet. I can put in an X value if I wanted to know what the moment was at 2, at 1, 1.5, like I said. Okay, so your X values are your inputs anywhere within that zone. Okay, so I'm putting 3 because that would be my maximum moment. So my moment here then should come out to, if I take 1900 times 3, 5,400 pound-feet. Okay, at section 1. Now let's go to our spreadsheet. And this time I'm not going to go down here to the internal shear. I'm going to go to the internal moment, and I know exactly what's going on here. This needs to be, what is that, 6? Yeah. I have to put this, I changed that earlier to 2. I got to put it back to 3. Internal moment. Okay. Oh, 57. Is it 50? It's 57. I wrote 54, sorry. 5,700. So now you'll notice that my section 1 internal moment is from 0 to D1. So my X input here is that maximum value of 3 that I just used for my manual calculations. Now, you'll notice that my moment at X1 is 5,700. Okay? That's that maximum value. This is the equation then to calculate that. So if I go back, here I know that my moment 1 is going to be the AY times the X1 that I input. So I go back over here. Here's my A1. That's that beam reaction C6. So if I go here, that's right there. And then my internal moments C7 is the value right from here, the X. Or you could also reference back to the inputs over here as well, because it'll automatically go there for the input, because this comes from the input for the X1. So here on the input, if I change this to 2, okay, I go to my internal moment, it went to 3,800. That's why it wasn't the same number earlier, because I changed that input. If I go back to 3, at that maximum value, the furthest point over, it's then going to be one of those milestones, if you would, on your sheet. Now, to check that 3,800, all you would have to do is pull up your MD solids and then put in a distance of, and you guys know how to do that, of 2, and then just make sure that your spreadsheet matches it. Okay? So you're going to want to generate this in MD solid so you can check your different values as you go along. Okay? All right, so let's go back, and that takes care of section number 1. Now let's look at section number 2. Okay. Section number 2 is going to be everything from 0 all the way to just before P2. Okay? So I'm going to draw my free body diagram doing the internal reactions up to and just before P2. So I'll call this section number 2. Draw this in. This is my A, so my AY was equal to 1,900 pounds. Now I'm going to include that P1, which was the 1,000, or we called it F1 on our spreadsheet, was 1,000 pounds, and then this distance was 3 feet. And then I am going to put in, right before P2, or the F2, this maximum value all the way over here of 6 feet. Okay? So that means that this is 3 feet. Now, internally, my reactions are going to be the same as they were before. I am going to have a shear. This is going to be F2Y, which is the shear for the second section. And then I'm going to have another moment, M2. Now, I'm going to check the direction that I put these in, and that's going to be based on whatever my positives or negatives come out to in my final answers here. So let's get the values for what my shear and moment would be at that 6-foot section right before the application of the 3,000 pound force. So I'm going to sum my forces in the y direction equal to 0. I've got a positive 1,900, got a negative 1,000, and I've got a negative F2y equal to 0. So my F2y is going to be, if I put this to the other side, a positive 1,000 minus 1,900, and that would be a negative, so actually these go positive, I'm sorry, negative and positive. I'm going to do it this way. So my F2y is going to be equal to 900 pounds. Ended up a positive value, so it just means that the direction that I chose was correct. Okay. Now, for the F2y, here's my equal sign in the spreadsheet again. So my 1,900 is the AY minus F1 for the 1,000 here. Okay. So as I look over at my spreadsheet, going back to the internal shear, section 2, this is going to be somewhere between whatever my D1 distance is and my D2 distance, the placement of each one of those forces. So I have to be in between there. So my X2 has to be in between whatever my D1 value was and my D2 value. So my D1 value was a 3. My D2 was a 6. So I have it at 6 right now to get the maximum value. My F2y, which is the shear force, is going to be equal to the beam reaction AY, which is our C6, minus our input of C6. So if we go back to the input of C6, oh wait, input C6. C6 was this force of 1,000 pounds. Okay, that was that F1. Okay, whoops. So that value is 900. Now let's do the moment for that section. I sum my moments equal to 0 here. I'm going to put in my M2, okay? And then I'm going to work left to right. Excuse me, work left to right, starting with my A. Oh, excuse me, again. So I'm going to have 1900 times, now this time it's going to be 6 feet, okay? Then I'm going to have, that's going to be a negatively directed, positively directed 1,000 times 3 feet, okay, equal to 0. Now, solving for my M2 is going to be equal to the 1900 times 6 feet plus 1,000, actually minus, right? Minus 1,000 times 3 feet is equal to 0. Now my 1900 is AY. Now my 6 feet here, we'll talk about that in a little bit. My 1,000 is my F1. Now, you'll notice here that from my placement all the way to the force. So let's look at this AY first. This number right here is going to be, I could put in anything along this section in here. Do you see that? Okay. So this is going to be my X2 value. Agreed? The 6 feet. So this is going to be X2 down here. AY times X2. Now, the next one though, okay, when I take my F1 and I figure out the distance here. Now I see the 3 here, right, because I placed it right at 6. But let's say I'm somewhere in between here. That means that this would be whatever my X value is minus, what was this value called? B1? Do you see that? And that's going to be the leftover distance then to here. So this is going to be X2 minus D1 is actually that value. You see, everybody see that? Okay. If you're not looking, that's okay, but this is kind of important because this sets up your spreadsheet. All right, so now this is going to be my equal sign here for my spreadsheet. So as I go back over and I look at moment number 2 then, internal moment, moment number 2, okay, you'll notice that I take my beam reaction C6, that's my AY, times input C11. Input C11, C11 is right here, the X2 value, okay? So AY times X2. Then continuing on, I'm going to subtract off input C6. Input C6 is going to be the force number 1, the 1,000 pounds, and then it's going to be times, you'll notice I start a new parentheses here, my input C11, which is my X2, minus input C8, which was D1. Okay? C8 is D1. C11 is that X2. Okay? Now, notice here that I put parentheses around that because I had to subtract my X2 minus my D1 to get that difference and then multiply it by the force. Okay, so notice there's an extra set of parentheses there. Okay. Now if I multiply that out, I will get 8,400, and you'll notice that that is the high mark on our moment diagram. So right here is where I was calculating for. That's that 6-foot distance right before the application of the force. 8,400 is our number. Okay. Any questions so far? Then we got one more section to do. Section 3. Okay. Section 3 is going to be looking at everything right before that BY. Okay, so now I'm going to start here at 0. I'm going to go all the way, all the way, all the way, and my x3 distance is going to be wherever I want to be, but somewhere in my third zone or my third section. Okay, so if I draw my free body diagram here, so this is section number 3. Okay. I have 1,900 pounds, which is my AY, 1,000 pounds, which is my F1, 3,000, which is F2, 3 feet, another 3 feet in between, and then this is going to be 10 feet, all the way over right before BY is applied. Okay, so I'm going to have an FY3, and then I think my moment switches. I'm pretty sure. Maybe not. We'll keep my M3 going this way. Okay. So now, let's calculate for the shear. So summing the forces in the y direction equal to 0. We've got 1,900 minus 1,000 minus 3,000 plus Fy3 equal to 0. So putting that all to the other side, I get Fy3 is equal to negative 1,900 plus 1,000 plus 3,000. Okay? Now, to avoid the negative before the 1,900, when I put this in, I can add this in any order. So I would start with one of the positives. So do like the 1,000 minus the 1,900 plus the 3,000. You could put the negative in front if you wanted to. I like to start and make them positive. It's just one less thing to maybe ball things up. So this is my AY, this is my F1, and this is my F2. Okay? So you'll notice when I look at my spreadsheet here, my Fy3 should come out to be 0. No, 2,100 was the BY value. Okay. Going back to my internal here. Now, you'll notice that for the equation for the Fy3, beam reaction, that's my AY, minus the inputs here, okay? Now, for my math, remember that your shear and moment diagrams are actually opposite sign-wise because you're internal as opposed to external. So even though if you set this up and you have a negative number there, that's okay. That just means internally it went up rather than down. The positive or the negative doesn't mean it's greater than or less than 0. It just gives you your direction. Okay? So 2,100 there. And then my internal moment, I'm going to calculate some of the moments equal to 0. I'm going to put in my M3 right away. And then I'm going to start on the left-hand side, 1,900 pounds times my 10, okay? That's going to be negative out front. Then I'm going to have a positive 1,000 times. Now from here to here is going to be 7 feet, right? Yeah. And then I'm going to have 3,000 times 4 feet at that 10-foot mark. And that'll be a positive, equal to 0. Now, I'm going to have M3 is going to be equal to, and this will be 1,900 times 10 feet, okay, plus, I'm sorry, minus, I'm going to switch to the other side, 1,000 times 7 feet minus 3,000 times 4 feet. Now again, this is my equal sign now for my function. So my 1900 is my AY. My 10 feet, okay, now don't use the length even though we're doing this for the maximum value. This is your X3 value. Your X3 is something between 6 and 10 feet. You could put 10 feet, but you could also put 6 or 7 or 8 or 9, okay? So that's going to be that one. My 1,000 is my F1. Now, this guy. To get to my F1, I'm going to take my, I'm going to call this my X2, and then I have to subtract off, do you see, D1 to get back to that distance. So that's going to be 7 feet in our case. So it's going to be 10 minus 3, but that's X1 minus D1. Everybody see that? Okay. So this is going to be times X3 minus D1. Oops. Minus. Then my 3,000 is my F2 times, okay? So here, this is going to be X3, and then I've got to get back to my F2, which is my D2 value, right? Okay. So this is going to be X3 minus D2, and then parentheses around that. Everybody see that? How those numbers correspond? So, as I look at the spreadsheet, I have right now my X3 value set at 8. All right. Let's see what it comes out to when I put it at 10. It should come out to 0, right? Because I'm at the very end. Okay. And it does. If I'm at 10 feet, everything came out to 0. That's why my moment goes to 0 at that point. And it's not an error. That's the correct value. If you put in something in between here, then those values are going to be different. And that's where when you run MD Solids, you can always check it to check what those different distances are for shear and moment. And for the 8, it was 8,400. So I'm going to go back to my inputs for X3. I'm going to put in 8. And that's going to be 4,200 on its way to get there. Okay? Now, let's look at the equation. Remember, you're pulling from the earliest places that you input them. So, our AY times our D1, or I'm sorry, times our X3. So, X3 right here is right there, so it's going to be the C12. That's what we have here, input C12. Then the next one is going to be the F1, which came from the inputs page, C6, times. Now, this is where I have my X3 minus my D1. That's from the input page. Both of them are from that first page. And then minus, this is going to be F2 times the X3 minus the D2. Okay? So, if I go to MD Solids, and this is what I'm wanting you to do, I didn't print all of this out, but if I go to MD Solids and I create this same spreadsheet, okay, so I'm going to do determinant beams, simply supported, 10 feet, oopsie, 10 here, enter. My first force is going to be at 3 feet, 1,000 pounds. Second force is going to be at 6 feet, 3,000 pounds. So this is what I printed out for you guys. Okay, so all of those values are the same. If I want to find those in-between values, for instance, if I want to set it to what is the shear in the moment at an 8-foot mark, okay, from 0 all the way to 8 feet, I go to options and I go to, I think it's diagram design, yeah, details, and I go to 8 feet and then enter shear and moment, This is that 2100 and the 4200. That's how you can check to see. So if I go in to my spreadsheet and I put in 8 feet for my X3, okay, I go to my internal moment, 4200 is the value that I'm getting, okay, and then here 2100 is the value I'm getting there as well. All right. So make sure that you do the MD solids. Now, the only other thing, what I did was I added for you on here, I added another set where all I did was I changed my distances, my overall length to 20 feet. And then just make sure that when you do that, you can leave everything else the same. Make sure that your values change accordingly like you see here. Okay, so it's just a way to check it. When you save your spreadsheet, this is what I want you to do. So when you save your spreadsheet, you want to save it in a way that when somebody opens it up, it's clean. Okay? So on this first page, these are all inputs that you put in. I want you to delete those before you save it. And then over here, that means that this is going to go away. Your internal shears should all go to, looks like these are zeros and division by 0, so that's good. And then your moments should all be cleared as well. So the goal here is that whatever you put on your input page kind of clears everything else, okay? Now, the other thing that I want you to do is make sure that you're not like, I want, when I open it up, this is just good practice, have your input page up and all the way to the top, okay? Not that it's down here somewhere and it opens up. You know what I mean? Because then you're like, what is there? So if I have, don't make sure I don't have to scroll and it's there. When I go to my beam reactions, same thing. Make sure it's at the very top here. Internal, don't have it down here the last time that you used it. And then the same thing for the internal moments, all the way up. Does that make sense for everybody? Okay. And then before you save, go to your input, make sure that that's the active page, because now it's going to save however you last went out of it. Okay. And then you're going to save it to your H drive in a directory, strength of materials, spreadsheets, and then I'll go there to see it. Okay. Call this one, what did we have for our assignment? Beams spreadsheet. Yeah, beams. You can do that. Okay. So this one, a little bit more thinking, and you have to do some of this manual work to identify your equations. So I encourage you, if you weren't copying this down as you went, you're going to want to go through that manually to help you set up the equations properly. Any questions?